First, let me introduce myself. My name is Himalaya Kakshapati, and I'm a AI consultant. I work in AI, especially for the US healthcare industry for more than 10 years now. And then I teach as well at the master's and the bachelor's level, just like you guys, right? Most of you, I think you guys are students mostly, and professionals as well, right? And then I train international clients from say NVIDIA, Qualcomm, Citigroup, right? And then here as well, Nepal Telecom and other organizations. I train them on Python, AI, ML, data science in general. Okay? And then, so today what I'm going to do is I'm going to try to give you an intuitive understanding of what, because I see that there are so many presentations on LLMs, prompt engineering, right, and such, right? So I'll try to cover what were, not there. Okay? So, first thing, I want to ask you guys, what is the number one thing that is, problematic in an LLM? Hallucination, exactly, yeah? So yeah, that's hallucination. That's because as hallucination means it just makes things up, right? And then it lies, but basically it lies confidently, right? Okay, well, I tried other day. I tried. Who is? I gave my name, right? Himalaya Kakshapati, and it just made up things, and it was saying she is, business, and then it was like it's so confident, very confident, okay. And then it's ridiculous, right? It's really ridiculous. So So anyway. So, let's just talk about how these LLMs work, right? Okay, so what is an LLM, right? LLM is large language models, right? Large language models, and language models, these are general models, right? And then, they're trained on a huge amount of data, right? Almost the whole internet, right? You guys know this, right? Everybody knows this, right? Okay? And what it does, let me quickly show you how it works, okay? Maybe you guys already know this, but so it's all, okay, 1 second. Okay, so how does LLM? LLM works, it's just nothing. LLM is very simple, very, very simple, right? It's just a skill of it. It's a skill, that produces this, this amazing results, right? Okay, it's just a one-word predictor. It's just a word predictor, right? Okay, what's the next word? It is a probability, right? That's it. Okay? At the end of the day, it's very, very simple, right? Okay, let me show you. Okay, for example, so the prompt is the best thing about AI is its ability to, right? And there are many words that complete. There's another word. Okay, there are so many options, right? Okay, so learn, predict, make, understand, do. Okay, they all are plausible. They're all plausible, aren't they? Right? But there are numbers. You see these numbers? Okay, what are they? They are probabilities, right? They are probabilities. Okay? So what it does is it creates a probability distribution, right? Distribution over the vocabulary, right? Okay, there's a fixed set of vocabulary. And then it just produces this, and then these are the, let's say, top 5. Okay, top 5 probabilities, right? And how? Okay, which one is it going to pick? The one with the highest value. Right? Is that so? Not always. Not always. Okay? And it depends on something called? Anybody know? Okay, which one you pick? It depends on another parameter, which is called temperature. Temperature. Okay? You guys know temperature, right? Okay? So what if the temperature is high? What happens? It will ask for more. Explore more. Okay. means, okay, in this context, what is it? It will pick, okay? So the higher the temperature, you have, it can pick not the highest, but it can pick any other, right? Higher the model, higher the temperature, there is uncertainty, means there is this randomness, right? So it could pick, for example, understand, okay, if your temperature is high, right? Or make any one of these, right? But if your temperature is low, what happens? If your temperature is low, what happens? Which one will it pick? Say temperature 0. The topmost or the highest probability, yeah? Okay, next one, yeah, that's correct. So that means if your temperature is very low, let's say 0, right? It will pick the highest one, which is what? Learn, right? Okay? So that's how it works. So now if there was no temperature, like say for example, it will always pick the highest probability, then what is the problem?
Then it would be a stop on an open maximum.
Okay. So basically, what will do, every time it will generate the same sentence or same phrases, same paragraph, right? Okay, and it will be really bland, very boring, right? Boring. Okay. So temperature is kind of spices things up. Okay, kind of. Okay. Okay. So yeah, let's see. Okay, so this blog is written by this Stephen Wolfram. Wolfram, do you guys have you heard Wolfram?
Yes.
Right, Wolfram. Yeah, he's a mathematician, right? Okay. All right. So okay, it's very readable. Okay, I really encourage that you read this. Okay, like over here. Okay, let's look at this. Okay, see, at 0 temperature, look at that. So at 0 temperature, okay, this is the text that is being produced, right? The best thing about AI is the ability to learn from experience. It's not just a matter of learning from experience, learning from the world around you, right? Okay, right, so anyway, but every time it's going to give us the highest probability, right? And then it's not interesting, as I said, right? Okay, so so it says that, okay, and Wolfram says that at temperature 0.8, this gives a very good, good balance, right? Good balance, okay? All right, so, okay, so where do probabilities come from, right? Okay. So how does it figure out these probabilities, right? So you give a prompt, right? So how does it figure out the next word? Like where do these properties come from? What do you think? Yeah, that's correct, yeah. Okay? From the data, okay? It just looks at the data, right? And from there, the occurrence of the word next to this particular word, right? Okay? Yeah, that's correct. But here, let's say, okay, so of course, the words are while training, right? While you're training, right? So you're gonna have to convert these words to what? You're gonna have to convert, because these models, any language model or any AI model, it cannot work with text, right? Of course, right? Everybody knows this, right? So we need to convert them to what? To 30? Yeah. We need to convert them to? First thing they need to basically do the tokens, of course, right? We do this, right? Okay? And those tokens are converted to what? Tokens are still text, right? Tokens are still text, right? Okay? So then these tokens need to be converted to before vector. There's one thing that's vector, automated vector, because there's an intermediate step. That is what? Token ID, right? Every token gets a token ID, right? Unique token ID, right? And that token ID is converted to vectors, right? Okay, so what is a vector? What is a vector? Vector is a? It's a different, excellent, right? Okay, and then of course it's just a bunch of numbers. It's a series of numbers, right? Okay, it's just a series of numbers, right? Okay, so then let me ask you. So I'll be doing a lot of questions. Okay. All right. So why vectorize? We already converted a token to token ID. It's already in numbers. But why do we need to, convert to vector? Why do you think so? Direction. Okay. Yeah, vector is the direction. Yeah. Whereas a scalar, the number is that. But what does the direction do? It's semantic. Excellent. Yeah. That's the word that I was looking for, right? Okay. Yeah. It's a semantic, right? Because these vectors encode the semantic, means meaning of the token, meaning of the word, right? Okay. So that is this is called what? This process is called. What is this process called? Embedding, right? Embedding, right? Okay, and then there are many embedding algorithms. And embedding, what it does is it converts these words into vectors which have semantically, these vectors, the numbers in the vector are created in such a way that similar meaning words actually they live together in this high-dimensional vector space. A vector are, you can represent a vector as an arrow, or you can represent a vector as a point vector, right? Point vector. So they actually live in a high-dimensional. I mean, if you have a three-dimensional vector, like this room is a three-dimensional space, right? And that vector actually lives in some three-dimensional space, right? And ChatGPT, right? GPT-3, 3.5, right? And what's their, how many dimensional vectors they use for their embedding?
No idea.
Okay. I think it's 300 dimensional, okay? And then every word lives in a 300 dimensional space. Okay, so we can imagine it, right? It's a very high dimensional space, but actually it physically lives there, right? Okay? And then similar meaning words are actually together. Okay, and then somebody said direction, right? And yes, the words have direction, right? Let's say happy is this vector, it has this direction, right? And the sad will be minus that vector, which is 180 degree. Right? Not exactly, but more or less. Right? Okay, you see that. Okay, so some of the speakers were talking about vector search. That's what it is. Every document is turned to a vector, and then you can do a similarity search, right? Okay, right? Okay, so and then I heard them mention about cosine similarity or something, right? Everybody knows cosine similarity, right? How do you do cosine similarity? That angles, yeah. Angle between two vectors, right? Okay, very good, very good. And of course, it's done through something called dot product, right? Okay. Now, what is a dot product? Sorry. Yeah. Exactly. Yeah, it's the multiplication of two vectors. But how? How can you multiply two? MSE, mean squared error, right? And we have this function, and we want to minimize that function, right? And how do you do that? We do backpropagation. But how does backpropagation work? What is the mathematical operation? Okay, so how does it work? Okay, yeah, you calculate what? Derivative, right? You know derivatives? Derivative, yeah, because you should know, you're an engineer, right? Okay, no, you're not? Okay, so every engineer should know derivative. Integral calculus, derivative calculus, right? Okay, so anyway, so what is the derivative? Derivative is what? Rate of change. If I change a little bit in x, what is my response in y? Okay, for that infinitesimal change, right? Okay, but we don't do derivatives here. What do we do? Partial derivatives, right? Okay, okay. So partial, because why do we need to do partial derivatives? Not the derivatives, but the partial derivative. Why? Because it's high dimensional. Right? First thing, if your x is one-dimensional, then a normal derivative would work, right? But if your x is multidimensional, then because you have more than one x components, right? So you need to do a partial derivative, right? and then partial derivative, okay, and then the partial derivative, with respect to each of the components of the input, right? Or weight, rather, weight, right? Components of the weight. Weight is also high dimensional, right? And then that is called that becomes a vector. And that vector is called what? That vector is called a gradient. You guys know gradient? Gradient, right? And gradient is a vector. And what does gradient do? Okay, it gives you a direction, right? So which direction does it, which direction the gradient points to? Towards the steepest ascent. Okay, it's showing the direction of the maximum steepest ascent, right? But we want to go downhill, right? So what do? We do minus of that, and then it shows you the steepest descent, right? Okay, and then there is a step size, right? And then we go slowly, step by step, and the learning rate determines how fast you go, right, along that direction, right? And then what you're doing is you're calculating the partial derivatives. You get a gradient, right? And that gradient leads you, and then so how to update these W's and B's so that the overall error is reduced, okay? And then you do it many, sometimes hundreds of times, right? Or thousands of times, right? And then all these weights and biases are, these are adjusted in such a way that you have minimal error, right? And that's, at that point, we say the network has been trained, right? Network is trained, okay? All right? And then, so what does it mean by the model has been trained? What does that mean? It's just, finding the optimal sets of what? W's and B's, that's it, right? Okay, so for example, if you download a pre-trained model from Hugging Face, for example, what are you downloading? What are you downloading? Anybody? You're just downloading these values of weights and biases. Nothing much, nothing. Just weights and biases, right? Pretty much, right? Okay? All right? And then it's very expensive to train because large language models are very costly, right? We need very high-end hardware, very powerful machines, right? And then, it costs a lot of money, like GPT-3, 3.5, right? They cost upwards of $10 million, okay? The conservative estimate, right? Okay? So anyway. So I think that's all about, that's all the time I have, probably, okay? So, I wish I could, go on further on this, right? Okay? So I hope you got some sense of, like the internals of these, models, okay? All right, so thank you so much, right? Okay? All right, thank you.